Hello, friends. What had happened was, after gear drives, we had skipped the belt drives, and we have parallelly we are discussing about steam formation, and so on from module one. Today, what I'll do is I'll give you a brief idea about belt drives, and later on derive the equations for the length of the belt, and maybe solve a couple of problems. Now, this is again this comes under power transmission and belt drives. Now, what are belt drives? If you remember, gear drives we call them as positive drives, and they were essentially used when the center distance or the distance between the two shafts, the driver shaft and the driven shaft, was less. But belt drives are most common drives. They are used to transmit motion and power between the shafts where the center distance is large. And very commonly, the two shaft axes are parallel to each other. uh, Unlike in case of gear drives, here normally the shaft axes are parallel to each other. Then gear drives, they cannot be directly made to rotate on the shafts themselves because the shaft size is too small. So there are additional machine elements which are called as pulleys, which are mounted on the two shafts, and then there is an endless belt which passes over them. And the main concept by which power is transmitted is through friction. So there is a friction between the belt and the pulley. Now, the pulley mounted on the driver shaft is called as the driver pulley, and obviously the other one is called as the driven pulley. Then belts can be made up of different materials as well as shape. Normally, we have either a flat belt or a V belt. Then we have a toothed belt, which are called as timing belts, and so on. But very commonly, in day-to-day operations, flat belts and V belts are used. The materials also can be rubber, leather, canvas, then felt, cotton, balata. Now, some of them are naturally available and some of them are artificially made. But anyway, for example, rubber and balata, they are secretions from some types of trees, and it's very sticky, and you need to process it, and then only you can convert it and make it into a belt. So belts can either be flat belts or V belts commonly, and the cross section of V belt will be trapezoidal in shape, and the pulley also in this case will need to have a groove. Later on, you will see the shape of the pulley which is used for a V belt. Then canvas and cotton belts, they cannot be used under damp conditions. That is, if the conditions are very humid, you cannot use them because they tend to stretch too much, and they also deform. But rubber and leather belts can be used in both the dry and wet conditions. Then, since an endless belt is used, the center distance between the shafts is more, and based on how the belt is made to run over the pulleys, we have two types of belt drives. Endless is, it doesn't have any end; it is continuous, and based on how the pulleys are mounted and how the belt is running between the two pulleys, we have two types of drives. One is called as the open belt drive, and the other one is called as the cross belt drive. Now, the open belt drive is the one where the driver pulley or the driver shaft and the driven shaft, they rotate in the same direction, while a cross belt drive will result in the driven shaft rotating in the opposite direction as that of a driver shaft. Then, for the same center distance between the shafts, the length of the belt will vary based on whether it is an open belt drive or a cross belt drive. So, when we derive the equations for the length of the belt, you will be able to understand this concept. So, here you can see we have open belt drive. Here, let's say this is the driver shaft and this is the driven shaft, and this is the belt which is passed over it. So, if the driver shaft rotates in the clockwise direction, then we have the driven shaft also, which will rotate in the clockwise direction. So this is the top view of the same thing. Then we have a cross belt drive, which is shown here, where the belt moves, it comes and it goes down and then comes in this direction. So in this case, what happens is, if the driver shaft is rotating in the clockwise direction, then the driven shaft, you can clearly see that it will rotate in the anti-clockwise direction. So schematic arrangement of the same is shown here, where we can see that both of them will rotate in the same direction, and in this case both will rotate in the opposite direction. Now, they have their own advantages, disadvantages, or comparison, and so on. So, what happens in an open belt drive or open belt system? Both the driver and the driven rotate in the same direction, while in the cross belt drive they all rotate in the opposite direction. When the shafts are horizontal or inclined, it is effective to transmit power. Here in closed belt drives, even if the shafts are vertical, you can transmit power. Then, as there is no rubbing point, the life of the belt is more. So you can see in the previous slide here, there is no rubbing action at all. But in this case, wherever there is a crossover, okay, at this point, the two belts will rub against each other, which reduces the life of the belt. Then, the length of the belt required is less in case of an open belt drive as compared to a cross belt drive. So this is the comparison between open belt and closed belt or cross belt drive. Now, what are the advantages and disadvantages of belt drives over other drives? You can have gear drives, chain drives, and so on. So the advantages are, they have sufficiently high efficiency. Then they can be installed in a very simple and easy way. Then belt drives obviously are suitable for large center distances. Then V belts can also be used for smaller center distances. Sometimes we may encounter a situation where it is not feasible to use gears, neither it is feasible to use a flat belt. So under such circumstances, we can use V belts and transmit motion and power. Then several machines can be driven using a single overhead power transmission shaft. That is what I do is, I will take a motor of a very large capacity horsepower and drive an overhead shaft and mount several pulleys on it. So if I have belt drives, there are several machines which can be run using the same motor, and whenever any machine is not running, we can just remove the belt and that pulley will run idle, that's all. But several machines can be made to run using a single transmission shaft. Then, due to reinforcement provided in the form of wires in the belts, they have a long life. There is no need for lubrication. Lubrication was necessary in case of gears. Here there is no necessity. Then endless belts with no joints are silent in operation. Normally V belts are made up of rubber and they are endless, but canvas belts or cotton belts, the one which you see in floor mills, okay, so there is a typical sound which you hear. That is because the belt has been made endless. It has two ends, but those ends are joined together using pins. So they make some noise. Then maintenance is less, as there is hardly any wear and tear. Belt drives are very economical ways of power transmission, and there is a provision to prepare belts of any material depending on the working conditions and the power to be transmitted and so on. So which means, for example, if you are working in a very dry arid condition, you can use canvas belt or cotton belt. But if you are working in a humid condition, you can use a leather belt or a rubber belt. So you have that flexibility. Then there are certain disadvantages also, like they are not suitable for very small center distances. Then velocity ratio does not remain constant, there is a variation. And slip and creep cause loss of power. What is slip and creep, we will discuss it in the subsequent slides. Then very high power cannot be transmitted effectively. Then the pulleys add additional weight on the shaft, and the pulleys for V belts have to be specially designed. So sometimes it may so happen that if the pulleys themselves are very large in size and the shaft diameter is small, then the shafts may end up bending. So you have to be very careful while designing the shaft as well as the pulley. Then when belts are intentionally made endless by joining two ends, as I took an example in case of a floor mill belt, a flat belt, they tend to make noise. Then the initial cost of the belt drives is more due to the cost of the pulleys and belt. And suitable bearings have to be used, and the pulleys have to be balanced properly. If the pulleys are not balanced, then the shafts may start vibrating. Okay, so these are some disadvantages. Now, I just use the term creep as well as slip. We'll try to understand what is the meaning of creep. Now, we know that whenever a belt is passing over the driver pulley and the driven pulley, and the driver pulley is rotating, on one side the belt is subjected to tension, and on the other side it will be, we call it as slack side. Okay, there is no tension. So because it is pulling, the driver pulley will pull the belt, that side will be under tension, and the other side it is releasing the belt, hence it is called as the slack side. Now, this difference in tension induces stress in the belt, and due to increased stress, the belt stretches. Okay, obviously, when you apply stress, there will be elongation. Thus, the belt coming out of the driver pulley will be in a stretched position, and as the belt approaches the driven pulley, it will be subjected to reducing tension. This reduction in tension results in contraction of the belt. So, there is stretching as well as contraction. So there is alternate stretching and contraction phenomena which occurs, and because of which there will be relative motion between the belt and the pulley surface. So this is called as creep, and creep results in loss of power as well as decrease in the velocity ratio. So this word velocity ratio, we had used it in gears also. Here also we are using, and the equations remain the same. So velocity ratio is nothing but RPM of the driving pulley, let's say N1, divided by RPM of the driven pulley, which is N2, which is also equal to the reverse, that is diameter of the driven pulley, that is D2, divided by diameter of the driven pulley, that is D1. Now we'll see what is the meaning of slip. Now we know that belt works basically work on the principle of friction. Okay, there's nothing else except for a timing belt, of course. So it is mainly due to friction that the belt drives the pulley, and the pulley, since it is rigidly mounted on the shaft, when the pulley rotates, the shaft also rotates. So there has to be friction between the belt and the pulley. Now, it can be shown that the difference between the tensions on the tight side and the slack side, that is T1 minus T2, if T1 is the tension on the tight side and T2 the tension on the slack side, that is equal to the force of friction. Now, when this above condition is met, then there is proper gripping between the belt and the pulley. But there are certain cases where there is a deviation. There is a difference in tension and difference between T1 and T2. So if this is greater than the frictional force, then slipping occurs. So here you can see if T1 minus T2, this one is very large, then the coefficient of friction between the slip and between the belt and the pulley decreases due to stretching of the belt. So under such circumstances, slipping occurs, and sometimes it also so happens that if the surface of the pulley is very smooth, smooth and shiny, then this also causes a slip, and normally this happens in case of flat belt drives. So here you can see the pulleys which are normally used. So this is the pulley which is used for a flat belt drive. This kind of a pulley which is used, and V belt, see, the shape is slightly different, and it has to be specially designed. There is a groove, and in this case, the belt what we use will have a trapezoidal shape like this. Okay, something like this. And uh, in lathe, if you remember, we had something called as a stepped cone pulley arrangement. So here we have a large diameter, and here we have a smaller diameter. Okay, so the reverse of this will be available on the other side. So if this is the arrangement which is mounted on the driver shaft, an opposite arrangement will be on the driven shaft, and depending on where you, how exactly you pass the belt. Suppose I pass the belt from this to a smaller, that is this size, on the other side. So what happens is, if you remember the velocity ratio, it is d2 by d1. So since d2 is lesser than d1, the velocity ratio reduces, but the speed of this will be greater, that is of the driven shaft. And now if I mount a belt, the same belt, if I remove it from here and then put it here, and on the other side if there is a larger diameter pulley, then this shaft will start rotating at a lower speed. So we can use it, or stepped cone pulley is mainly used for speed variation. Okay, so this is all about belts, and various definitions, velocity ratio, types of pulleys used, advantages, disadvantages, and so on. So what we'll do later on is we will derive the equation for the length of the belt for open belt drive and cross belt drive, and looking at the equations, we will cross check whether the length of the belt which is required for a cross belt drive is more or not. Okay, then there is one more equation which you will have to just remember, uh, based on which we'll be solving some problems or some numericals. Okay, so that we'll see it in the next class. Thank you very much.